Okay, this is 14.5.5, another directional derivative problem. In this case, we wanted the directional derivative of this density, and the density is provided by this function, 1 over the square root of x squared plus y squared plus 1. We want it at the location 2, 1, and we want it in a direction that runs along the angle pi over 3, counterclockwise from the positive x-axis. I'm going to build that actually into a vector. So the vector I'm going to use is a vector that would point along the hypotenuse of a 30, 60, 90 triangle with the 60-degree angle at the vertex. So that would be a vector that went over 1 and went up radical 3. And that would make it 2 of the 3 sides of a 30, 60, 90 with the hypotenuse being 2. Now, of course, unfortunately, this isn't a unit vector. So let's change it into a unit vector. 1 squared plus radical 3 squared is 4, and the square root of that is 2. So if I divide these by 2, it'll make a unit vector. So my unit vector in the same direction will be 1/2 and radical 3 over 2. And now it's a unit vector. Okay, so we need the gradient, and then we'll plug in our 0.21 to the gradient. So I want the gradient of rho. And what's that going to be equal to? Well, first, if I treat this as x squared plus y squared plus 1 to the negative 1/2, it's a little bit easier to take the derivative of. The partial with respect to x is going to be negative x times x squared plus y squared plus 1 to the minus 3/2, because it started out at the minus 1/2, so it drops down by 1. And the y coordinate's very similar. It's negative y, and then x squared plus y squared plus 1, also to the negative 3/2. Now, this would be a pretty unpleasant gradient, except I'm immediately going to plug in the 0.21. So what that does is it reduces this down considerably. Now, del rho at the 0.21, after I do all the substitution and simplification, is going to be negative 2 over 6 radical 6 and negative 1 over 6 radical 6. And I'm not going to simplify that one right now. You'll see why in a little bit. Okay. So there's rho, and there's our unit vector. So we just want to take the dot product. That will give us the directional derivative of rho in the direction of our unit vector. So the dot product between the partials is going to be negative 2 over 6 radical 6 with negative 1 over 6 radical 6. And then I want that vector dotted with 1/2 and radical 3 over 2. And that produces as products, it's just going to be negative 1 over 6 radical 6 plus, and this one's also going to be negative, so minus, and then this will be radical 3 over 12 radical 6. And you can see to put these together, I just need a 2 in the numerator here. So this is going to be negative outside, 2 plus radical 3, and the whole thing's over 12 radical 6. And I could again rationalize the denominator, but there's no reason to. This is the directional derivative of the function rho at 2, 1 in the direction of this unit vector.